Hello everyone, today I will continue with the lessons learned episode of Voron 2.4. Basically, I will go through the whole manual and try to give you tips and tricks. And let's start. The fourth page is related about choosing the STLs and it's like a legend. It's explained the naming of the STLs and there are a couple options on the STLs files. For example, if you want to go the Bowden, you don't need to print direct feed parts or is same as applied for the dim brackets legacy and cable chain and or zip chain. And the next one, the fifth page, is related about the slicer settings of the printed parts. So if you want to print your printed parts by yourself, so you need to use this slicer settings. The walls needs to be 4 and solid top bottom layers needs to be 5, etc. And there is another, if you don't want to print by yourself or if you don't have any working 3D printer, there is a printed forward program on the Voron. So basically, you are ordering the 3D printed parts, and these parts will be printed by other Voron owners who are approved by the developer team. So you can use that program also. But you need to be aware that PIF printed forward programs only provides you to functional parts. For example, they are not printing or sending the skirts for these cosmetics parts. You can print them later on once your Voron is working, but you will get all the functional parts. And of course, the Voron has Discord. If you are planning to build a Voron, you should definitely join the Discord, and you can ask questions once you faced a problem or you have a question, etc. And also the GitHub, all deliverables can be found under this link on the GitHub page. Also, they have another repository for the user mods. In there, you can find mods. Just check the GitHub page, and like I said, you can find all deliverables like this manual or STLs or all the things. These are again legends for the drawings, and you need to start the frame, of course. So you will have a different length frame, but it's a very nice visualization. So at the same length, and for 10, it should be 10, I guess. Yeah, there should be a 10 extrusion with the same length. So you will use these, and again, there should be a 4 same length extrusion there with the 2 holes at the end. So you will also use this. And while you are doing the blind joint, this is I think the more convenient one. You can also use corner cubes, etc. But I would recommend to you go with the blind joint. It's more rigid, I guess, what I'm thinking. So for that, if these are pre-tapped and pre-drilled, it's slightly easier for you. But if you want to do it yourself, you need to be careful about the position for the drilling. So this drill needs to be drilled at the center when you think about the width, and there should be a 10 millimeter offset from the bottom or from the beginning. This is important because you will tighten this screw while you are putting your Allen key from these holes. So if these are not in the correct place, you will not get a 90-degree square frame, basically. You drilled maybe wrong place on the wrong place at the first, but you can't extend the holes. But be careful about these hinges, these. So since the head is holding these hinges, you don't want to powder these ones. You don't want to drill this part, but you can extend the hole. But best option, like I said, just don't bother yourself. What I would recommend you just buy pre-drilled and pre-tapped. And if you are doing yourself, just be careful about the position. And while you are tapping, you need to keep on mind that go half turn while you are tapping and come back a quarter turn. So with that, you can prevent the powder stoppage in your tooth. So this powder can break your tooth and it can give you a headache. And also keep in mind that this cast needs to be flush, because if it is not straight, if it is not 90-degree cut in here, so you will not get a square frame, because this part this part will sit on this place on the other extrusion. So when you tighten the screw, it will force that. If it is degreed, for example, assume that it's a 5-degree angled cut. So your extrude when you tighten your screw, your extrusion will tend to move to left a little bit, and you will have 95-degree. So actually we are aiming 90-degree, so it will not be square. While you are putting them together, you should use a flat surface. You can use big mirror, big glass, or countersink. But yeah, keep in mind that it's not a rocket science. I mean, it will be a tiny bit out of square, but it's not a problem. It's not a big deal. As long as these diagonal measurements, the difference between these diagonal measurements is under the 2 mm, it's okay, the developer team saying, but I try to keep it under 1 mm. So like I said, just do your best and try to keep this difference under 2 mm. Then you will be fine, because later on you will mount the parts also that will force your frame to be square. So keep in mind these diagonal measurements under 2 mm, and you'll be fine. And using flat surface is a big deal. It's really helping. Keep in mind that also. Yeah, it's explaining the squareness. And yeah, these frames for the beds, you later on you will put your bed on these two frames. Don't forget to use shim where the manual is indicating. So at the beginning you are placing these at roughly positioned. You don't have to be precise at this moment. Later on you need to align these with the DIN rails if you are using DIN rail. So later on it will be aligned. And later on you need to put your Z rails. So for the Z rails first you need to clear the shipment oil. You can use isopropyl alcohol to clean it. And after that uh, apply a little bit grease. This grease will help this carriage to move smoother. You don't need to unassemble the carriage, just I did, just apply a bit grease where the balls are, the back of the carriage, and run through this carriage back and forward, and keep this process until you are happy. Also, you can apply on the rail, but it's a little bit time consuming, but it's required. And while you are putting your carriage on your frame, use the center rail installation guide. It's on the in the STL folder. You have to print these two. So one in the top, one in the bottom. So this will help you to center your rail on the frame. And like it's also mentioned, you don't over tighten these bolts, and you need to bolt it every other hole. What I did basically, I just put my installation guides and align my T-nuts. After that, I screwed them, just took the empty part, and at last I tightened all screws on the rails. So all Z rails are doing the same way. And after that, you will start the Z drive assembly. So in the Z drive assembly, and yeah, by the way, I recommend you put your all heated insert at the beginning, just before you're starting your build. So yeah, instead of opening your solder and putting this heat sort every time, I think it's more convenient to do them at once at the beginning. So the for the pulleys, for the grub screws, you need to use a thread locker, and you need to be careful about that. This rotor where the doing the rotational thing, can say, this mill should has one flat surface. It should like a D shape. So one of the screws needs to sit on this flat surface. With that, it will hold you the rotor longer. It's less chance to become loose, what I'm trying to say. And you need to do the Z drive shaft. For that, just follow the manual. Like here, you need to place one bearing, 625 you are using in the Z drive shaft. And after that, you need to put 8T teeth, and you need to put two shim bearing, two shim, 22 pulley, 9mm one, and another bearing. So keep in mind that if the bearing is touching another part, you need to place shim. So you need to do 4 times this one. And again, don't forget to apply thread locker on your grub screws. And after that, you need to run your belt and put your drive shaft on the modules. And you need to screw them together after that. And again, you are putting this nut for the foot. Okay, you are putting this nut and facing down to modules. You are screwing it, and after that you need to screw your foot. Then later on you need to put the Z motors. Again, you need to use 4 screw, and keep in mind that the pulley on the Z motors, the toothed side of the pulley is looking for the motor, so the thick side is looking for the outward. With this, you are trying to reduce the force that you are pulling your motor to your shaft. So do it like that, and if you do other way, also it will not align, I guess, with the shaft. So do it like that. The thick part should look the outer side. And again, so there are 4 of the Z modules, so you need to do these steps at 4 times. After that, you are just placing the bottom panel. So these are the bed frames. You need to put this panel on your bed frames, and you are putting your thin rails on top of it. And with that, you are like doing a sandwich. It's also saying that. And in this step, you are aligning these bed frames. So it should have the panel should have the cutting, and through that cutting you are screwing this sandwich to frame with the nuts. So with that you are aligning the frames where the bed sits. After that, mount your Z drives on your frame. While putting the Z motors, don't forget to put this latch. This latch actually for tensioning your this closed belt. So once it's open, it's relatively not tensioned, and with this position you are mounting your motor, and don't tight at this stage, and just took the empty part of the screw, and after that put the latch on its place, and it will tension the closed belt, and after that you need to tighten these bolts. And let's go through. Yeah, these are the Z idlers, nothing to be special, but for the I actually put this, yeah, this part is moving up and down with these bolts, and with these bolts you are tuning your Z belts. So I try to be precise with doing that. What I'm trying to say, I just screw this bolt till the T-nut. I mean, the ending of the part was flush on my sorry, not T-nut, hex nuts. So with that, later on, I cut my Z belts at the same length, and since these tensioners are also same position, my Z belts relatively were in the same tension, so it's helping a bit. So I would advise you to at first putting these screws with the flush with the hex nuts. So and these pulleys needs to be rotate freely as you expected also. So don't tighten these bolts. So it should only hold this pulley. Just be sure that the head is flush with the plastic part, and that's okay. Don't tighten it. Later on, you are placing the Z idlers. Be careful about the orientation and build plate. So yeah, in the build plate you have aluminum bed and you have silicone heater and you have thermal fuse and plus you have earth connection. So you need to, if there are not, you need to drill two hole for one for thermal fuse and one for earth connection, and just put your silicone mat on the bed and wait for 24 hours with putting the weight on it. And after that, do the same for magnetic on the other face. Yeah, again, put some weight and wait 24 hours. And later on, I also applied, it's a common practice also for a lot of users. I also applied our high temperature silicone, RTV, for the sides and the corners. So it will help the Hilcom mat and sticking to aluminum bed strongly. So with that, we are aiming to not lose sides of the silicon mat. So we are trying to avoid the dangerous situations. And some Voron owners putting this thermal fuse on the heating mat with the RTV. You can also do like that. The purpose of this is if there is a failure, if the silicon mat peeled off the aluminum bed, so since the thermal fuse will be stick to silicon mat, it will still read approximately the right value, and if it is heat up more than 125 or what the thermal fuse is rated, it will break its wirings and it will cut the main feeding for your bed. So with that, it's again they are trying to avoid the dangerous situation. However, I placed my thermal fuse on the aluminum plate itself because the high silicon temperature, the RTV, is not good at the heating transfer. So yeah, I thought that this is actually can cause a problem since the heat will not be transferred directly to thermal fuse because there will be RTV between the heated mat and the thermal fuse. So that's why I put my thermal fuse on the aluminum plate itself. I also applied a little bit thermal paste between them. It's not necessary. I just had it and just applied a bit and screw it. Yeah, to be honest, I'm not expecting my silicone mat will peeled off my aluminum bed since I used RTV and also the sticker on the silicone mat is very strong. However, we always try to be on safe side, so take your measurements for that. Do what you want, you can place on the silicone mat with the RTV. And let's continue. Yeah, and remember that you need to put a thread locker for all grab screw. This is the Z end stop pin. So in the Z stop pin, you need to deflange the one of the pulley, 22 pulley. It's easy. I just used my pants to remove this like it was like a shim part. It's saying the 33 millimeter shaft, so it can be changed, but at the end you most probably you'll be fine. The only 1-2 millimeter difference should be between the your Z pin and your bed. So it can be 1 millimeter up or 1 millimeter down. It's okay. But for now, you don't have to be precise about it. Just place it for now. Later on, once you install your Z and stop pin and your bed, do the visual check. So if there's a, for example, 4 millimeter difference or 3 millimeter difference, I would advise you to change your pin accordingly. And also do this after you are certain about your pin. But I again advise to do that. You need to create a notch. It's not necessary, but I would advise to do. This notch, it helps you to hold the pin. What I'm trying to say, you will create this notch and you will screw this grub screw a bit. You will not tighten this one. It should be loose. Your pin needs to move freely. But for example, you will change something on your electronic parts and you turned your printer upside down. So in that case, if your Z and stop pin can fail. So in that case, and if you don't realize that or you forget to put in the back in place, and if you home your printer, your nozzle will go down and will press your pulley until something breaks, I guess, or you will cut the power. So it can create a dangerous situation. So I would advise you to create this notch. You don't need to be precise. Just you need to place, yeah, you need to place grub screw set. That's all. Like I said, I would advise you to do that at the end once the ZN stop and your bed is installed on your frame. For the ZN stop micro switch, you need to remove the lever if there is, and you can use JST connector. It's your choice. You can use also directly the wire it. And yeah, but yeah, in this stage it's saying you to put your bed. However, I put my bed at the end. The reason of that, while you are building it, you need to turn your printer a lot. So the bed is really heavy. So that's why basically I put my bed at the end. I would advise you to the same. Also, while you are putting it, it's recommended that you use 3 screw. Put your bed, but don't tighten this yet. Once your printer is commissioned, just hit your bed and wait for an hour or so. Tighten one of the bolts, and the other two should be firm. It's like should be touching like the plate only. That's all. Otherwise, it's a possible that your bed could be a taco. I mean, because once you hit aluminum bed, it's trying to extend a bit, and if you tighten them both ends, it will not have room to extend. It's very small, but yeah, it can affect your bed flatness. So I think mine is affected. However, I didn't tighten the all four of them or all three of them, but again, it's my bed is now it's not flat that much. It's showing me zero point 0.2 difference in the corners. I'm not sure. Maybe the heat cycle caused that. It's not a good one. I'm not sure. Yeah, but like I said, heat your bed and wait for an hour or so. Then tighten one of them, and the other one needs to be firm. That's all. And yeah, the Zen and stop position also. Be careful about that. There should be a 2 millimeter or so empty space between the aluminum and your pin, because we want to prevent the hit this Z pin to success the accuracy. And later on you will start your AB drive modules. And yeah, again, this is the, like I explained before, this is the bearing stack. You need to use shim at the beginning and the end. So with that, place your shim on the idlers, and yeah, be careful about the shims. Just because yeah, this shims helping the bearing to rotate freely. And another thing is also it's uh, it's, it's your belt is aligned with the design. So if you not use shim in here, your belt will be a millimeter down, millimeter offset, has a millimeter offset. So don't forget to put shims, what I'm trying to say. And yeah, nothing special in here also. This arm is movable. So with that you are tensioning your AB belts. So again, like in the Z idlers, determine a position and try to keep the position same for the both. So you will have two for this. So try to keep position of this arm at the same with these two. it will help you tensioning the belt. And AB drives, it's nothing special. Again, since there is a plastic, it's since there is a plastic body, you will have one bearing stack in here, and you will have two in here. And yep, placing the stacking them like this orientation is helping you, like I said. Put your screws first on this printed part, then place your stackers of shims, stackers of your bearings. And after that, place your upper parts and just screw them. Yeah. And while you are installing the motor of the ABs, the one of them, the pulley of the motor, the one of them will be upside down, then the other one will be placed normal. The thick part will look to motor. Be careful about that. This is because of the belts will be top on each other, so that's why you are installing like that. And again, we are installing the rails. So again, you need to use the center guide. And first, install one of the rail on your frame. Then tighten tighten this one. And after that, since this is installed, you cannot use the centered rail installation guide. So in this case, you can just snip off one of the leg in here and use it. I did like that. And but don't tighten the second one, because later on, once you install the afterburner, you will move your head and try to find the home position of your second rail. So one of them will be placed rigid, the other one just took the empty part. Don't tighten them yet. And yeah, it's true, nothing special. Yeah, the Y rails. After installing your idler on the frame, put your Y linear railer on the frame. Be careful about the orientation, like in shown in here, and the your rail needs to be flush with the idler. Be careful about that. And while you are putting this, don't tighten these screws yet. Don't tighten the bolts while you are using to mount your idlers and AB drives on the frames, because later on you need to do gantry racking. So just again, took the empty part and don't torque them yet. Again, same applies for these, and you need to be careful about this. It needs to be flush with this part. And let's move on. Yeah, don't torque these bolts yet. Yeah, there's nothing special. And the head, and if you are using Omron, the M320 is not enough. It's not long enough to, since its geometry is different than the Omron. I think you need to use M325. Keep in mind that. And these are for the belts. Yeah, yeah, and this is the pivot. Yeah, yeah. So this front part, the front rail is the rail that you tighten, you torque them. So for the second one, for the bottom one, so mount your head, and after that move your head left and right, hold the rail, and after that put your head at the rightmost and try to torque your screw of the rails. Torque the first of them and move the second one, and torque second of them, move the head the other one, etc. And another thing, while you are installing your rails, I'm trying to remember which one's causing the issue and find in the manual. Yeah, let's find it. Yeah, for the this bolt, there is another bolt on there are another two bolts on the bottom. So for the the second bolt, you need to install a T-nut as you are expecting. However, if you use the last hole of your rail, this T-nut is intersecting with the rails T-nut. So that's why you need to leave it empty, the last hole of the rail. So with that, T-nut will has space for the placement and you can screw it. and it's not a big deal. You can, if there is another empty hole, you can use the second one, second from the at the end, second from the end. But yeah, don't use the last one in his on this and on this. Be careful about that. And I think it is same story for this one also. Again, there is a front idler while you are putting your front idler. So this there is a hole nearby the front idler. Don't screw it in here. Use the other one. So with that, you will have space for the T-nuts of the front idlers. Yeah, we put the head, and yeah, manual says the run your belts in this stage, but I would recommend you do not. I did like that. Later on I just removed them because for me it was easier to put my gantry on the frame and do the gantry raking without belts and do the other stuff. So for now, I would recommend you not run your belt at this stage, but it's your choice. Yeah, depending on your hot end choice, you need to print or you need to get the printed parts and do the what the manual says. Nothing special in here, but yeah, be careful about the orientations and don't forget to use the thread lockers on the grab screws. And in here, it's yeah, this hole is little bit has little bit length. With that, you can move these printed parts up and down a bit. It's for the adjusting your gearings. So after putting your shaft, yeah, you need to place it like that. So since there's a movement, you can adjust this part up and down, and yeah, you can position your gearing as it should be. And yeah, after installing the clockwork, you can do the manual check. Yeah, it was the case for me. The grab screw was not tight enough. It said it's not flush. What I mean with this gearing, so it was scratching this 3D printer parts while it's rotating. I was feeling when I rotate this while I'm doing the check, while I rotate this, at certain point it was not moving by hand. It's stucking, what I mean. So I checked that my grab screw was not flush or got deeper from the pulley, so the grab screw was powdering my the 3D printed part. Be careful about that also. In here especially, the grab screw needs to at least flush with the gearing or it needs to be go deeper. And yeah, just follow the manual in here. And let's see. Yeah, and another thing while you are putting this, we did we pass that? Let's see. No, okay. Yeah, while you are putting this fan, your wire should has the length. What I mean, once this opens, it's a movable part. This part is coming like this, approximately 90 degree. So once it's opened, your wire should reach your fan again. So while you are placing your fan, be careful about that. I basically run my wire like this, like not diagonal way, but the 90-degree way. So it helped me in that. In here, it's a little bit confusing. In here, so what I would recommend to you, just build these two stacks. So put your hex nut in here and put your cap in here. And with these two parts, install these two part your gantry. I mean in here. While installing this one, also check your Z belts first. They should have same length. You can use the tooth method that I showed. And for the bottom part, you are placing this bottom. So for the bottom parts, also install your Z belts and install them like the belts needs to be flush in here. So after that, uh, install these ones, these bottom parts, on your rails while your gantry not installed your frame. So you need to install your Z-belts and these two printed parts in the frame, and you need to install this part, this curved part, to your carrots. After that, apply a little bit grease on the top of it. It's helping this joint a little bit, not that much. And after that, put your gantry in place, and with this screw, put them together, but not over tighten this one, because these parts have a room little bit. Because since it's gantry, this, for example, this corner can drop a bit, or for example, once your head is in the back side and your steppers off, you will see that your back of the gantry go down a bit. So this joint is helping you that movement. So that's why you don't want to over tighten this one. There should be a room for movement. After putting after putting the gantry on your carriage, then after that run your Z belts. Again, since it is flush in here, so just run one of them, and while you are putting this screw, by the way, you can use zip tie or a rope to hold your gantry. Just zip tie from here, for example, or rope from here and somewhere in here, while you are gantry somewhere in here, and slide your carriage and screw them. And after that, run one of your Z belts. Pull the belts in convenient way while the tension is nearly good, and tighten these bolts and count to tooth, how many tooth is remaining from this part till the end. After that, apply the same thing to all your Z belts, but since you know the happy tooth number, you can apply for all the rest, for all three. For example, if there are 10 tooth is remaining in here, so remain 10 tooth in here, remain 10 tooth in here, and remain 10 tooth here. So it will be relatively same tension. This is nothing special. These are, yeah, if you have the skirt, you can place them. Again, I placed them at the end. By the way, be careful about the orientation of this one, because don't ask me how I know. Yeah, in this skirt, the flat part needs to be looked to outside of your printer. So it's the other skirts are like this curved part is looking the outside, but this middle skirt, which is holding the fans, the flat parts looking the outside. So be careful about that. Yeah, I advise to put skirts and the panels at the end. At everything is finished. Once everything is finished. So you ran your Z belts. Where are we? Oh, yeah. Now you ran your Z belts also. Now you want to do the gantry racking. So for that, put your gantry in level in a way with the just measure in the one corner, for example, adjust it 20 centimeter from the top of the rails and to the gantry, and apply to same measurement to all. So your gantry will be square in a way. So after that, just follow the gantry procedure, and while you are doing the gantry racking, and you will also tighten, torque these bolts, this one, and the bottoms, of course, and these ones. So follow the gantry racking procedure. After that, run your AB belts. So I think it's more convenient in that way. Like I said, you can also install them at the previously when the manual shows, but I think this one is more convenient. It can be a little bit harder, but yeah, it's worth it. It's not that much hard also. So you just use the tweezers and It's easy. And there's a common mistake that is doable, which is running your belt in the AB drives wrong. So remember that your belt needs to turn either a bearing stack or pulley. So sometimes the peoples are running the belt. For example, there is a plastic part on here. Sometimes the people are running their belt over the plastic part. So it's not going that way, but going like this. Coming the belt this and this. It's the wrong way. So keep in mind that your belt needs to turn via bearing or pulley. It's of course it's always the case. It will not turn over the plastic part or any other part. Be careful about that one. And yeah, like I said, I would recommend you put the skirts and all the panels at the end. Lastly, the wiring. You can check also my wiring episode. I explained how you should do it, and it's also shown in here the connection. But important thing is in here, don't do all wiring at once. What I'm trying to say, for example, first do the wiring on your power skirt first. After that, plug the cable and with multimeter check your wiring is correct or not. If it is correct, unplug your cable. Then after that, run your main wire for the 24-volt power supply. Again, after running your wire, plug your uh, plug your cable to power skirt, and with your multimeter check the voltage in the 24-volt output. If you are getting 24 output, then unplug your cable and do the second one. Repeat this until you are the devices, the components are finished. So don't do it once. With that, you can easily diagnose what is the issue, and it's the, I think, safe way, because assume that your 24, you did the test for 24 volts and it's working, huh? Then you will run your 5-volt power supply, and let's assume you ran your main wire for the small power supply and plugged your cable, and you are checking and you are not getting 5-volt in here. So you can easily say that, okay, there is an issue in the wire which is between the my small power supply and the source, if it's I mean the terminal. So you can easily diagnose it. So later on, for example, after unplugging your cable, you can do continuity check with these wires and see if the wire is broken or something. Or you can check the input in here, 224 volt. If it is coming 224 volt and there is no output, that means your power supply is not working, etc. But imagine that if you ran all the wire at once and something is not working. It's okay, it's again diagnosable, but the other way is more convenient and less time consuming, and it's more safe, what I'm trying to say. Just follow these diagrams. It's not easy, just follow the wires, and that's all. So in here, it's if you are not using Vago or terminal, in here you are using like a terminal. So your mains coming in here and it's distributed from here. That's all. It's nothing special in here. Yeah, and if you are not using IGOS chain, if you are using Chinese chain or three hole, which has three hole ending, there are mods on the GitHub repository. Just check them. You can use them. I am also using them, so it's again easy. And yeah, and for your low current wiring, for example, your the wiring which is coming from the tool head and going to your electronic chamber. First, you run your cable chains. After that, run wire from the tool head, follow the cable chains and go to the electronic compartment and go to furthest points and add 30 centimeter approximately and cut your wire. And with this, referencing this one, cut the other wires as how much you need. And after that, start crimping from here and run your wires, and you will access wires on the electronic chambers. Just do the routes and run the wire with those routes, and once you reach the where should it be connected, just cut it, crimp it, and plug it. That's all. But don't cut your wire at the exact length what you need, because you can do the wrong measurements, or yeah, it's always saved. It's always good to have more what from what you need. You can easily cut them, and that's all. But if it is short, then you need to run the wire again. And for the cable chains, don't use the socket head, use the button head. And if you have flat one, use the flat one. But if you don't have, use the button head. Don't use the socket head, because your wire will run on top of it. So it's not a good way to run your wire. Since it's moving, it can scratch in your button head screw, and at the same time it can be broken. And once your wiring is also finished, you can put your skirts and your panels, the remaining parts. By the way, I forgot to tell you, but it's same applies. While you are running AB belts, same method with the Z1. But in here, don't make it flush. So leave 2 centimeter or so in here at the beginning of your belt, and screw the cap and run your belts, and again tension with your hand a bit, and again leave 2-3 centimeter, and count your remaining excess tooth, and apply same thing for the other belt. So with that, and also if you position them roughly at same place in the idlers, you will have equally tensioned belts. That's all for the lessons learned episode. If you have any questions, just let me know, put in the comments. And thank you for watching. Thanks for time, and see you in the next one.